Hello, and thank you for joining us today. My name is Lauren Clare, and I'll be moderating this webinar. Today's webinar, entitled Making IoT Real, is presented by Arvind Ramchandra, Chief Architect at Altmetrics, and Scott McCarley, Senior Director of Solution Management for ThingWorx. Arvind Ramchandra is the Chief Architect of Altmetrics, driving technology and solution strategy across industries. He's extremely passionate about innovation and has been the key driver behind the IoT initiative for multiple customers. Arvind has over 19 years' experience as an accomplished technology practitioner with a proven record of leading strategic transformation and innovation initiatives for multiple businesses. He has been leading the technical transformation across companies such as Wipro and OCWEN Financial Services. Arvind has been an entrepreneur and a speaker addressing issues like technology strategy, business transformation, innovation, and industry thought leadership. Scott McCarley is Senior Director of Solution Management at ThingWorx, a PTC business, where he's focused on enabling customers to leverage the Internet of Things to deliver new value and transform the way they create, operate, and service products. He has responsibility for the leadership of market analysis, solution definition, and go-to-market activities for ThingWorx smart connected product offerings. For the past 5 years, Scott has worked with leading manufacturers to help elevate their product development, service, and supply chain management capabilities. Scott has over 15 years of management experience with enterprise software companies in roles ranging from software development to marketing. Scott holds an MBA in Marketing and Strategy from Carnegie Mellon University and a BA in Biology from Colby College. If you'd like to ask questions during the webinar today, please do so via the Q&A tab at the bottom of your screen, and we'll address and answer questions at the end of the webinar. We will also be sending out the presentation slides as well as the webinar recording after the presentation is made available. Now I'd like to hand it over to our first speaker, Scott McCarley. Scott?
All right. Thank you very much, Lauren, and thank you all for joining us today. Waiting for my slide to push out. Lauren, can you confirm that the slide is showing from your end?
Yes, I can see the slide on my end.
All right. So I apologize, folks, a little bit of a connectivity issues from my side. Hopefully they won't introduce any hiccups for today. We'll march right through, though. So smart connected products in the Internet of Things are transforming product capabilities, customer relationships, how value is realized across businesses, and the very nature of industry competition. According to McKinsey, the Internet of Things and smart connected products will introduce $6.2 trillion in new global economic value annually, beginning in 2025. McKinsey also points out that the manufacturing and healthcare industries will be the #1 industry sectors to capture that value. If you haven't read the Harvard Business Review article on the Internet of Things, on Internet of Everything, written by Professor Michael Porter and PTC's President and CEO Jim Heppelmann, I'd encourage you to do so. One very nice quote about the economic opportunity coming from Professor Michael Porter is that he points out that smart connected products will introduce more productivity growth than the earlier impact that even the introduction of the Internet itself had. So smart connected products in the Internet of Things present to you an economic opportunity of a lifetime. What's behind this transformative opportunity? Well, it's an explosion in connected devices. So companies like Cisco, Ericsson, GE, McKinsey, they're all predicting enormous growth in the number of connected devices, with 50 billion devices being connected by 2020 and up to 1 trillion in 2035. Very nice quote from John Chambers, the CEO of Cisco here, is that without applications, there's no real value in the connected devices. So it's in fact the applications that expose the value from connecting all of these devices and introduce this new economic opportunity. So if we look at 2020, the expectation is that there'll be 5 million new applications that are needed to run the devices, and over 100 million by 2035. These are applications that you can't buy off the shelf today, but need to be created. So what makes these new applications extremely innovative? Well, it's the fact that they connect machine data, so time series information from these devices, these connected devices, along with transactional data from enterprise systems, like such as ERP, or perhaps some sort of Google weather information, as well as information from people themselves. So it's the ability of these new applications to combine people, systems, and things that really makes these new applications innovative. Here at ThingWorx, we're working in sort of 3 separate markets where we consider smart applications, such as the smart agriculture, these connected systems, smart agriculture, smart cities, smart buildings. We also work in connected operations environment, where folks are connecting the assets they own to derive new value throughout their value chain, their organizations, as well as connected products, which is the products that companies manufacture. So connecting those to derive new value inside of their organization, provide new value to their customers. Today we're going to focus on connected products. I think it's a most relevant topic. Altmetrics had some fantastic success here, working with other businesses to help them with their connected product strategies, as well as introducing their own offerings in the healthcare space. So every manufacturing industry is impacted by smart connected products. You may think it's only most relevant to one industry, but I would challenge anyone to think of an industry that's not impacted or can't derive tremendous value from it. We've worked with customers across all of the discrete manufacturing verticals represented here. Just to pick off a few that are very relevant, and you can learn from other industries. In industrial equipment companies, we're seeing customers deploy 30% fewer trucks to service their equipment in the field. So by being able to remotely diagnose and access information, they're reducing the number of times they need to deploy a service technician. In consumer products, companies are now able to identify customers whom they never had a relationship with before. You might be familiar with warranty cards, but those don't have a tremendous success rate. New connected applications can offer that way for you to identify which customers are using your products. In the medical equipment company, certainly at-home care is a huge movement. That industry in general is undergoing so much transformation that lines up extremely well with the Internet of Things and smart connected products. But certainly smart connected products enable a much better treating patients at home by communicating that information right into the hospital or to all the members who need that information. There's an interesting example that we'll look at later about in commoditized industries, such as in industrial equipment, being able to leverage real-time information from their manufacturing equipment to derive brand new revenue streams and provide brand new value to their customers and really differentiate their offerings in the market. If you had to distill down what is the business benefit of smart connected products, you could do so and summarize it in pretty much 4 value opportunities. The first is it's an opportunity for a manufacturer to improve their customer's experience. So leveraging data from the connected product to improve their ability to service the product, to improve their customer support. So if someone called in, they'd know the information from the product instantly, and to improve the customer's usability, product usability for the customer. Additionally, it'll enable them to optimize their internal business processes, so taking that real-time data and combining it with their internal existing systems. It enables them to provide new differentiated offerings in the market, so to differentiate themselves from competitors by providing new product innovations as well as new service innovations. And finally, very important to all businesses in manufacturing firms, new revenue streams. So enabling businesses to unlock and capture brand new sources of revenue that they weren't even participating in, or markets they weren't participating in previously. So I think people can understand very easily how a smart connected product in the Internet of Things can introduce new customer-facing value, right? So in certain instances, new product capabilities that the customer will benefit from. But for many businesses, and the majority that we've worked with, the real easily identifiable business benefits are from within their own walls, right? So taking that real-time data from an asset or a product in the field, putting it into a product cloud, but then being able to integrate it with their existing enterprise systems and existing business processes to derive new optimized business processes across multiple organizations in their company. So this is just a simple example where we're taking real-time data in and providing it perhaps through a service lifecycle management system, SLM, to a service department. And by having that additional insight into the real-time data, if a customer service representative picked up the call, they'd know instantly what the usage of that equipment was in the field. If there had been an error report triggered from the product, they would see it and be able to provide a much higher level of customer service. They'd also be able to schedule maintenance activities, not simply based upon a calendar but based on actual needs from the product. So you can see how their department would be greatly improved. In sales, if you were able to receive real-time customer usage information and be able to populate through the sales organization, they could be able to cherry pick which customers they would need to communicate with regarding perhaps needs for an additional piece of equipment or a complementary offering from the company. So they might see that a customer has is utilizing an asset at its 100% maximum output and could benefit by the addition of a new piece of equipment. So that's really a benefit to sales. Inside of operations, maybe you're entering into a consumables market, and they can actually, by looking into the product, see if it needs new ink or perhaps some sort of detergent or any consumable associated with the product. The engineering department, through product lifecycle management systems, so if we could feed that real-time information into the design process, so that usage information into the product lifecycle management system and their design system, so that they could make superior design decisions moving forward based on real-time usage, would be tremendously powerful. Inside of finance, there's a huge movement from companies to go from selling a product to selling a product as a service. And that's done by getting real-time usage information into your finance department so that they can charge for the customer using the piece of equipment. So the challenge for most businesses is that while they clearly can see the value of smart connected products and the Internet of Things to their business, they need to identify which IoT opportunities they're going to go after first. So they need to prioritize use cases with a cross-functional team within their organization. They then need to be able to quickly deliver IoT solutions. Time to market is a critical differentiator here, right? So companies have the opportunity to establish themselves as leaders in the market and capture brand new sources of revenue by being the first to market with a solution. But they're not only bringing one solution, quickly trying to deliver one IoT solution to market, they need to establish a strategy for sustained IoT leadership. Right? So they need to be able to scale efforts and deliver transformative value across their entire organization. So we've had the benefit of working with leading manufacturers and leading businesses for over 10 years. And based on that, that experience, we've developed a model that shows how the typical company, a typical manufacturing company, delivers value with smart connected products over time. So again, there's no one-size-fits-all model for all companies, but this was a great example of a typical company. So most companies start in the realm of service. So trying to leverage the Internet of Things to provide better service. And this is really kind of the, at least within the manufacturing space, the killer apps are often viewed as being here. And that's because they're so easy to justify and to generate significant ROI for these activities. If you can remotely monitor and access and address issues on equipment, so access and repair equipment remotely, it's just very easy to calculate the ROI, as you know what it costs today to deploy field service technicians. So being able to reduce that is tremendously valuable and easily justifiable within an organization. But once companies tend to get that service data, right, or collect real-time data for the purposes of service, they start to analyze it, looking for additional value that they can exploit within their organization. So things like, well, what if we studied this data to see if we can spot trends and sort of move to a predictive maintenance model instead of that calendar maintenance model that we talked a little bit about earlier? Or perhaps we can just share this real-time product usage and product status information back to our engineering department, and they could find additional value, or with their sales and marketing. So once they start to analyze it, they find they have some real new business insights that they're deriving from that information. It has real value. And once they distill that information, they then look to integrate it with their existing enterprise systems and their existing business processes. So moving from an ad hoc analyzation into an integrated process where they're moving that data, the insight, that business insights, and integrating it into their enterprise systems. so that real-time data and analysis flows freely into their enterprise systems. That enables things like closed-loop product lifecycle management, so for the design process, incorporating for the service department, that service information with their knowledge management systems, so that customer service rep might even just click a button to see what the knowledge management report states for that event that occurred. And also being able to close, you can certainly see quality and risk, right? So getting that quality information, not just that an error occurred, but what were the conditions around it? What was the temperature? What was the performance of the equipment? Was there, humidity levels that were maybe, in unexpected places? So once they've integrated that information, they then seek to really transform themselves and innovate in brand new ways. And that could be by exposing more information to the customer, sort of providing brand new sources of value to the customer in terms of mobile applications. And things like also enabling a customer to personalize their products in brand new ways, really create a new product experience. Or exploiting those new business models that we talked about, whether that's selling the product as a service and entering brand new markets that enables, or entering into tangential adjacent industries such as consumables, or perhaps even services. So not just selling the product, but actually operating it on behalf of your customer. The challenge that most businesses face today is that their internal conventional application development operations are not well designed to meet the needs of their IoT apps, right, for delivering applications on top of their smart connected products. So the reasons for that are they need to first internally identify who has the expertise to be able to transfer information from the product, so putting an agent on the product or asset device in the field and communicating that from either an agent on it or near to the product and communicating that across the network. That requires particular expertise. Then they'll need someone with expertise who can receive that information in a cloud environment or perhaps on-premise, but cloud environment to process it securely, manage and store that information coming from the product. Then, once they've done that, they then need to build the application that to fulfill the use case they're envisioning. So they need to architect a data model, write integration services potentially with other applications, whether it be ERP or other cloud-based applications. They need to code the business logic. They need to write security and user permissions associated with the app, and design and build an interface. Once they do that, they'll deliver a fixed application. So for example, we might have a field service application, or let's take even a customer, since we spoke about it earlier, a customer support application, right? So now we're exposing to the customer support people information about this product, real-time information from this product. But as soon as they build and deliver that application, there's a request from another department. So shown here might be that field service person in a mobile environment through a mobile interface. So they've requested an app. And now the internal IT team that's been tasked with building this is unable to fully leverage and reuse the efforts from their first application they built. So it's likely a different team, and they'll need to redeliver the entire stack of technology. Additionally, the first application that you delivered, someone has already asked for 6 changes, or 16, or 600 changes. I think we're all familiar with the pace of change regarding software, and there are new feature requests and all sorts of new needs. And then again, as soon as you're managing that, another team comes along and asks for a new application. The net result is that you've delivered different applications using a non-standardized technology, redeploying effort with an audience of IT personnel who maybe don't have this as their core competency skill set. And then you need to manage the change. The result is that this is complex programming where internally it's very difficult to maintain and evolve. It comes at a high cost, and ultimately you're delivering something that's an unproven, there's unproven scalability and unproven security associated with your offering in a long delivery time frame, which is ultimately a barrier to your own company's ability to innovate. Really, this is the role of an IoT platform, is to simplify that process and to enable provide technologies for companies to build those applications quickly. So an IoT platform at its most base level will connect your product via IoT connectivity middleware, so securely communicating that device information and from sensors and into the cloud. It'll then have a device and data management layer that would securely collect and process that information and provide capabilities to remotely monitor, manage, and service those assets in the field. And then what really distinguishes an IoT platform and really distinguishes the ThingWorx IoT platform in particular is a rapid application development environment. So having tools that are purpose-built for IoT application development that would enable you to rapidly build new applications for your diverse audience internally, leveraging and reusing the work you've already produced to enable you to deliver quickly and scale over time your IoT needs. If we look at the ThingWorx platform in particular, we have the most comprehensive platform offering in the market today. If we look at connectivity, starting at the bottom of the stack, we see that we've worked with hundreds of ecosystem hardware partner providers. We've tested a ThingWorx Ready program to ensure that their hardware products can communicate. They work with our agents or have standards supported that communicate instantly into our device management cloud area. We also have an always-on connectivity, so it's a bidirectional communication at the IoT connectivity layer. And then within that device cloud, we've proven its scalability. We have millions and millions of connected devices today. It's been proven out at hundreds and hundreds of leading manufacturing customers and leading customers across all sorts of industries, whether it's in also some of the smart agriculture or even into the connected operations, sort of the smart manufacturing environments. So it's proven out that it is a secure and scalable solution, end-to-end solution, that can be delivered in the cloud or on-premise. And what really separates the ThingWorx platform from all others is the rapid application development environment. So this is a model-based and codeless development environment. So first you model the architecture of the system, and so that you can reuse and have really an object-oriented environment. But then we provide a codeless development environment that allows you to drag and drop interfaces so you can quickly deploy new applications for a diverse set of users to enable specific activities that they need. It combines information from people, systems, and things. It's social and collaborative, meaning it combines that information, rich information from people, and it leverages a large ecosystem of partners that we have today. So if we were to look at the applications that people use to connect to a smart connected product or their assets and devices, what you could do via the application development environment, you could build a custom app. You could use an application built by one of our partner ecosystems. Or you could use a sort of apps for remote service, so basic functionality that we provide that enables you to do common activities like remotely monitor, access, and update software on your systems today or on your smart connected products in the field today. And all of this is easily integrated through services with other systems such as business enterprise systems, big data analytics, and cloud services, other cloud service offerings. The net result is that ThingWorx is going to deliver to you the fastest method and most secure and scalable solution to deliver new applications, IoT applications, to market. I want to just take a quick spin through our customers and be mindful of my time here. So at ThingWorx, we've worked with, just as a quick snapshot of some of the discrete manufacturing verticals that we've worked with. And we're working with leading companies, but we're also working with those brand new innovative application companies that are really trying to disrupt the business models and are some very successfully doing so. I wanted to just walk you through a few examples along that same maturity level perspective of just some customers and how they're getting value at each of those different maturity levels. So Diebold, you're probably familiar with as a provider of ATM equipment. So by using our solutions, they've been able to reduce the problem resolution time from hours to minutes. And what that, now, today, they can resolve 17% of the issues that they can resolve remotely used to require a field service visit. So from a technician to actually visit the piece of equipment. That's an incredible cost savings for them. The overall uptime of the machine has been increased, and the statistic here is reducing the downtime by 15%. So, from a customer perspective, that's a huge differentiator. For a reason you would buy a Diebold piece of equipment is because it has such a guaranteed uptime because of their ability to remotely address these issues. Electa, so they're a medical device equipment maker that resides within hospitals' four walls. They too are experiencing a reduced number of 20% reduction in service requests or the need to deploy a technician, but they're also leveraging that information, the real-time information, through analytics to really deliver preventative maintenance programs. So they're highly focused on machine uptime, right? That's the most critical, one of the most critical metrics in a hospital environment because that, directly relates to patient therapy, patient safety. They need the machines to be working in order to guarantee, a sort of a well-functioning hospital, but also to engage, to provide that safety level. So they're moving to a preventive maintenance schedule to guarantee uptime. GE Power and Water is just a nice example of a business that's been able to take real-time data and share it with all departments in their organization and find value. So whether that's changing the way they operate with sales, so commissioning salespeople no longer just on how many products you sold, but on how much those products are being used as they've moved to contractual SLAs. So they're selling the product as a service because of their ability to get that real-time information. They're also doing things like, if we skip down, look down at number 6 here, they're optimizing their inventory. They better understand their spare part needs because they can look into the equipment and see what's going on, where they're going to need spare parts, and ensure that their inventory levels are optimized. And that's real cost savings inside of their organization. Some nice examples of innovative new things. So entering those new markets one is Joy Global. So they produce mining equipment. So based on the real-time information they were capturing from their mining equipment, they recognized that they could in fact operate the mine more efficiently than the customer could. So they now operate mines on behalf of their customers and not just collect information about their own products, but from other products as well. So they're entering into a brand new adjacent industry because of the new value that real-time information is providing them. Another nice example is Altmetrics. Right, so they're the manufacturer of these traffic signs that you see in the road. And, we have them here in Boston where I'm located. And you see these traffic equipment in the road, but they're not just providing static information to you. They're communicating information back to a traffic cloud in the instance of Altmetrics here. So that Altmetrics now doesn't just sell the equipment; they sell the data that the equipment collects and the integration to this traffic cloud system. So they sell new services, and in fact their largest source of revenue today is the traffic cloud. So they can enable people to not only control the signs remotely, providing new signs, say go left, there's traffic up ahead, but by mashing it up with information, traffic information from providers like TomTom, they can automatically route traffic and reduce congestion in areas. They can provide that information to their constituents, sort of local transportation departments of transportation, so that those departments can see where their traffic equipment is deployed, how they could optimize that, enable them to control the signage to reduce traffic patterns, but also to do things like capture images directly from the equipment and understand if there's a battery or tampering issues. So there's all sorts of additional value that they can provide through their equipment or to their customers with these new IoT applications. So with that, I'm going to hand this back over to Arvind from Altmetrics to talk. And I just want to mention Altmetrics is a fantastic partner and is a great example of a business that's working in multiple ways with us, not only as enabling manufacturing customers to bring their smart connected products to market, but also introducing new solutions. And I think you'll enjoy hearing from Altmetrics here. Arvind, can I turn it back to you?
Hi, Scott. Thank you. Thank you very much for this. Thanks for the introduction, and also to ThingWorx for getting us on this wonderful forum. As I can see, that the attendance is quite a huge one that we have, and I'm assuming that we'll be able to capture interest like how Scott has for the last 29 minutes. So we'll proceed on that. So what I'll do is, and of course, given that we have about 30 more minutes, I'm going to spend exactly about 20 minutes just giving a quick snapshot. So not about the industry itself, what Scott has already done, but we'd like to focus on a few points. And of course, one is, I'll start by giving a very quick brief and so about Altmetrics itself, right? And so what we are and what is it that we do, what are the areas we cover. But then I'll very quickly go into what we are actually doing and so on the ground with respect to IoT. So as you can see that the theme of the entire discussion today was, right, so making IoT real. So what we feel is that IoT has at least started moving out of the hype domain, right? And so while the numbers are really very interesting, but we think that IoT is happening, right, so, and so getting real right now, not in 2020, but in 2015. And that is what we will talk about, right? And so how are the different industries and how the different segments within those industries leveraging IoT, leveraging the technologies, and and so what are the different ways that they're doing it? Because and so what we are seeing, which is very surprising, is the fact that the way that these companies are leveraging IoT has become very, very contextual, and so very specific to their particular business model. And I think that is probably some of the challenges that we'll also talk about. We'll also talk about and so what our view has been as a practitioner. So what you see on the screen is a quick fact about Altmetrics itself. So we're part of Verticuti Ventures. Uh, and so our CEO is Raj Verticuti, owned and founded Covansys quite a few years back. Was a pioneer in the IT industry, but now we're moving into technology-based and so version, very heavily investment oriented. We co-innovate with a lot of our partners and even with our enterprise customers. So we are about 2,500 plus people all over the world. We're headquartered in Michigan in the US. We have centers, I think with major centers in Bangalore, Chennai, and India. We are certified across from a lot of other compliance, industry-specific compliances. So our customer snapshot is it's very broad-based. We work across major industries, automotive, healthcare, and financial services being a very big piece of it. You will see some of the customers over there. We also partner with a lot of the leaders from a technology, leadership perspective. So you can see some of them there over there, SAP, Salesforce, HP, ThingWorx, quite a few more when it comes to leveraging specific technologies. Now, what has typically been our approach with all of these customers is that we want to use these capabilities, and we want to use technology to power the business transformation, because what we feel is that the entire industry and the way the technology is being delivered to them is itself undergoing a transformation. So it is not about just doing an ERP project anymore. It is not about just doing a web enablement anymore. And so what business needs is a combination of all of these technologies, which is where we see the real challenge coming in. And so which means that and so what you have in terms of traditional models, pretty much to what Scott was talking about, right? And which means that those traditional models of doing application development, those traditional models of deploying and releasing them also will not work. So which is where we focus on. So what we have is a set of capabilities built around these particular technologies, what we're calling any device computing. So it's not just about mobile, but also extends to all kinds of devices. That's one. Second is, right, so the entire analytics part, which is what we're calling as information visualization and engineering. And then the whole thing about the customer experience, which is why we're calling it as experience-led design, because the way that these applications will actually get viewed and used by the end users is also going a significant transformation. So bringing all of that together is where we want to focus on. We're focusing on digitized assets, on cloud enterprise solutions, and connected solutions for a pretty completely different world. And then you have the industries on the right-hand side. So for all of this, specifically from an IoT, we are leveraging the ThingWorx automated partnership to the maximum. And so I'd like to say it's almost 360 degrees. Not only are we just an SI partner, but we do real implementations of IoT turnkey projects for a lot of the manufacturing customers, but we're also a powered by partner where we use ThingWorx, make it a part of our platform and solution offerings. So for example, we're building something for healthcare providers, which includes ThingWorx, and so where we actually monitor medical equipment running within operation theaters and different kind of ICUs. We also are building industry-specific solutions where we're extending the usage of ThingWorx platforms and their components because we think that's where the real value lies. Now, this could be specific to service management in manufacturing. This could be specific to care management in the healthcare world, or it could be specific to payment mechanisms coming up in the retail world. So, which is why we're working on industry-specific solutions. We also are developing very quick based upon Salesforce solutions for some of this, right? So where we are now putting up into marketplace, right? So in the marketplace, we are developing something more from a starter kit perspective. right? So which will allow you to integrate different kind of platforms for Salesforce, for example, or SAP or other ERP platforms. We're also creating different kind of frameworks around ThingWorx, something that will support and extend the functionality of ThingWorx itself, supporting mobile devices, supporting analytics, supporting complex event processing, integrating with other industry standard products. So this is the kind of ecosystem which we are creating along with ThingWorx, and we found it to be an extremely successful partnership. And of course, we think that will go much beyond and so what any of us will imagine. So what are we doing in this particular thing, right? And so from an IoT perspective, what we are doing essentially is connecting the dots, right? So the dots start off from different kind of machines, which is what we see on the right hand side there. This could be motors, this could be pumps, this could be furnaces, this could be engines, or this could be medical devices. So what we are seeing is that the nature and the way that these particular equipments function, they also determine what is the kind of model that you would want to use, what is the kind of sensors that you need to put in to actually capture that information. And once you have the data, how do you get that out of the equipment itself, which is where, and so we explore different connectivity options, right? So you could go cellular, you could go Ethernet, you could go different kinds of wireless protocols, etc. So we work with a lot of our partners along with ThingWorx in terms of, and so what are the right kind of gateways. Then we have, and then we have the edge or the node, what you would call, which is where the data gets aggregated. Right? So once you apply the rule on that, so what do you do with all of the information coming from the sensors? Right? So you need to process them because these are all coming in streams. These are all coming in multiple bytes per second, etc. So, but what do you do with all of these event streams? Like, so what Scott was talking about, based on the time series of data which is coming out from the machines. So you need to process them, so which means you need to have specific rules by which you process them. So that's what something that we're working on, along with partners like Intel, partners like Syslink, who are also part of the ThingWorx, and they have ThingWorx ready, and so gateways and edge nodes. So we actually develop applications around that. We have a complete ecosystem to actually help you to create rules, create the business logic around this particular data. So once that is done, right, so we then after that, of course, use the ThingWorx, the Thing server side, this deployment, which could be either on-premise or cloud. We use this completely to also create the right kind of dashboards, the right kind of applications, and for the right kind of channels, whether you want to use it on your tablets, whether you want to use it on your smartphones, or whether you want to use and so want to view it in the browser. We also integrate this particular thing because, and so without integration to the traditional systems like the ERPs in the manufacturing world, or it could be the EHR systems like Summit and Epic in the healthcare world. So this is what we mean by connecting the dots, right? So because it has to be end to end, that's when we're seeing that the real value also comes out. So what is our strategy towards all of this, right? So how do we want to connect these dots? And this is a very rough diagram, very rough this thing, not as appealing, not as cute as some of the pictures that we have. So but this brings out all of the layers pretty much very similar to what Scott was talking about. Right. So we have the different layers. So you have the physical components at the bottom, which is all of your mechanical, electrical, electromechanical equipment. We then have the smart components, which is what makes them smart. All your sensors, different control systems, different PLC systems. And then we have the connectivity components, different kind of ports, antenna, embedded connectivity components, and etc. But then you have the entire architecture on top of that, which is where smart applications come in. What we are doing is, along with ThingWorx, we also partnering with a lot of the people in the ecosystem that's enabled by ThingWorx. A lot of them have ThingWorx ready, ThingWorx certified platforms and applications. So we're leveraging that very, very significantly. Now, where are we seeing this as actually being applied? One significant this industry is the manufacturing. So, but the way that manufacturing is leveraging this is turning out to be very interesting. So, for example, and so we went to a manufacturer of an industrial equipment, specifically around furnaces. Right, so these people now wanted to know what was happening inside a furnace, when it was actually in so being used for a specific job. Right, so what we did was we put about 24 plus sensors, and so across 4 different zones in the furnace. So there's a hot zone, there's a cold zone, there's a high pressure zone, there's a humidity zone. We put sensors across all of this. We are now capturing all of this data in real time. So we get data almost every half a second. We have this complex dashboards, which then warn them about what's happening in each zone, it also predicts and says that, right, so because of something happening in hot zone, this is a problem that can come up. Now, this is a pretty expensive piece of equipment which is used by a lot of the automotive manufacturers around the world. So Volkswagen themselves have about 28 of this running within their plants. So each job goes for about 3 hours. You have very high temperature, 2400 degrees Fahrenheit. So any damage can turn out to be extremely expensive. So which means that they need to know what's happening. So not just control, right? So they already have PLCs, but these PLCs only control the furnace operations. They do not provide insight into what's happening within the furnace, and it doesn't allow you to actually track every kind of a parameter. So what we did was we actually implemented this whole system. It is now being rolled out across different geographies across the world, and it's also being now going to be put into different models within their own thing. But the interesting part is the fact that the use case was very different. Right? So because what happens is when they design these furnaces, they are looking to design, and of course because more than 60 to 65% of the furnaces are actually customized very, very specifically to what that particular end user might need. For example, if Volkswagen needs these furnaces, they will design these furnaces in a specific manner. What they wanted to know was that is there a way that they can reduce the cost of what goes into a furnace and actually customize all the components that go into the making of the furnace. That amount of information and all of the insights that the sensors and parameters provide is what helps them to optimize the design of a furnace. So not only does it help in the traditional way and in what we understand, like what Scott was talking from a service management perspective, but the benefit is actually in terms of even the equipment design itself. They now know that, for example, instead of putting 25 graphite rods, since I can get the same kind of a temperature, I can get the same kind of hot zone performance by just putting 23 graphite rods. So what they're actually getting is they're saving the cost for 2 graphite rods. Each one costs about $1,500, $2,000, which is a significant sum when it goes into the manufacturing segment. That is one particular answer what we're seeing. Now the same kind of scenario is what we're seeing with one other AC and DC motor manufacturer, where their business model is because they take up fixed contracts where they go and so install motors across, for example, specific packaging plants. So they're looking for cost savings, I think. So it is not, and of course, while the service management is a very strong one, what we are seeing is some of these more unconventional use cases are something that is coming up, which is something very surprising, but which also means that we now need to create the right kind of models specifically supporting those kind of particular use cases, right? So apart from the usual ones which we have seen. So this is from the manufacturing where we're seeing a huge amount of uptake. So what you'll see here is something around the architecture, right? And so where we leverage ThingWorx very, very effectively. So you have the industrial furnace, you have the sensors on top of that. So we use certain kind of SCADA equipment to capture the data coming in, and then we use the edge microserver provided by ThingWorx, which is running on, for example, right now it's running on a SysTech device. That SysTech device also has event processing running on that, which is integrated with the edge microserver. I'm getting a little technical here, right, for a few seconds. So all of the data now goes into an on-premise ThingWorx server, which then services, analyzes the data, provides in the form of different kind of dashboards, and these dashboards now send out different kind of alerts. These alerts are available on the mobile device. They can quickly respond. But also, and so what's happening as an interesting side effect is that now these manufacturers are going to actually create a display which will run along with the PLC control display. So this display is going to be purely only for the dashboard itself. So what happens is as a furnace supervisor is walking around supervising all the furnaces, the dashboard will keep flashing different kind of signs. If he sees the red coming up on the hot zone or on the pressure zone, he can immediately click on that. It will show him all the details. He immediately switches over to the PLC and then performs whatever correction and operation that it needs to do on the furnace itself, for example. So that's the kind of use cases that we're seeing very strongly developed. Now, while that is in the manufacturing, and of course we'll be happy to write and so answer any questions as part of the Q&A, but also be happy to of course show all of this thing and how it works. But the other scenario which is a little more challenging when compared to the manufacturing is in the healthcare world. Right, so it becomes challenging because you have a lot of regulatory and compliance issues to be taken care of over here, and also that the equipment is pretty complex because it is not integrated equipment like the manufacturing world, where it is one engine, where it is one furnace, or it is one set of motors. Here, it becomes a variety of different kinds of equipment. You've got ECGs, you've got oximeters, you've got blood pressure monitors, you've got anesthesia equipment. All of this data coming in from different kinds of equipment, which need to be used in different ways. So what you see over here is, of course, right, so a very quick thing on the architecture itself. So this is a little more complex because these are equipments running within the hospital or provider premises. So which means we need to take care of quite a lot of aspects in terms of HIPAA compliance, security needs, data privacy, and plus the way and the mechanism that you would actually want to share all of this information out. Now, while that is on the application side, the bigger challenge on in terms of the healthcare scenario is also the devices. So these devices need to go through a specific FDA process. And what I'm putting up over there, what you see on the slide is a very quick example around that particular aspect. I'm just doing a quick time check. I think I have about 3 more minutes so before I can Q&A. So what I'll do is I'll very quickly go over some of these other scenarios. But and so from our side, what we realized is that while the technology side, like ThingWorx, this thing has been great in terms of enablement, we also think that there is a layer on top where it needs to be made specific to industry, which is where we work very closely with ThingWorx and all of their executives, or solution partners, and all of the domain experts, not only within this one area, but across these areas too. There's one other use case which I'll quickly jump into and then I can wrap up. So this is for an engine manufacturer. Now what we noticed here was that there is a need to actually bring in different kinds of products together. Right, so as you can see, right, so each scenario has a different kind of a usage. So manufacturing is very integrated. One large device, put sensors, grab data, process the events, you're done with it. Healthcare, slightly more complex because you need to take care of compliance, security, regulatory issues over there, plus the variety of instruments coming in. Whereas in this particular thing, what we saw was that the use case is for an engine manufacturer, where we need to grab information coming from the engine, put different kinds of sensors, and sometimes this could be all kinds of micro sensors. But the information coming out of engine diagnostics now needs to be integrated with a lot of information coming in from other products. So that's, and which is what. So if you see here, for example, right, and I'm just going to keep switching between screens a little bit. So sorry for doing that. So but what we're saying is you need information about the engine design. We need to be able to locate and point out and say that, hey, this is where the problem is. We need to have engine diagnostics code, right? And then we need to have the entire knowledge management system around that, integrating with CRM systems and etc. Because this is more of a service system, and the support structure, the business model is most of the people who are supporting it are not even employees of the manufacturer directly. They could be agencies and distributors and etc. all over the world. So here we saw that, and so what we saw was that we needed to integrate a lot of PTC's products. For example, Creo, because it had all of the engine designs, and then Windchill because it had all of the product lifecycle information, and of course Servigistics because it was doing a lot of the service management activities around that, and then came ThingWorx on top of it, which sort of brought all of the IoT part of it also together. So all of this, and so bringing it together this way, what we are seeing is, right, and so I'll take a short pause before I move on to this, and I know I have only about 2 more minutes, so sorry, a minute left. But this is the reference architecture, which I'm sure that all of you will be very familiar with. What we're seeing is that the left-hand side is where the real challenge to the industry this thing is actually becoming, because you have different kind of equipments. Each one, we need to understand what is the kind of, and so what's the kind of data output coming out of this? Is it continuous? Is it event-based? And then what are the kind of sensors that you need to support that? Once you get this data, what do you do with it? What is the kind of connectivity? How do you process this data? Which is where we think that the focus is going to start shifting from the right hand side, which is cloud and integration and everything, is going to start shifting all the way to the middle and to the left, because that's where the action is going to be. Right? So how can you process data on the edge? For example, right, if I have a healthcare device being monitored, right, I might not want to wait to go to the cloud, have the latency of a few 4-5 seconds and everything else when you want the data to be shared very quickly. So you will need to do a lot of processing at the edge itself. And so which is where we're seeing that a lot of the challenges, and which is where we have been working quite a lot with ThingWorx and so many of the partners in terms of making use of all of their components. So this is where we think where we see a lot of action happening from a technology perspective, but from a business perspective, what we think is that there are going to be very contextualized models, but there are going to be a lot of patterns emerging. So what Altmetrics and ThingWorx both of us are doing together is actually creating those patterns specific to each industry, whether it is industrials, whether it is healthcare devices, whether it is standard manufacturing process, and so on and so forth. Thing across this, those patterns is what, right? So we continue to offer to our customers, where it allows them to accelerate the adoption of IoT and also allows them to start adapting their particular business models and get the benefits of IoT. So I'll take a pause here. I know we're almost close to the hour. I'll switch over to the questions, then start answering some other questions that are coming through.
Sure. Thanks, Scott, and thanks, Arvind, for giving some great presentations. So we have a good amount of questions in here. First question I have, I'm going to just direct them to both of you, and you can both answer or one answer, however you feel is best. The first question we have is, how do you convince customers to accept being connected?
Hey, Arvind, Scott here. Maybe I can take a quick pass, and you can as well. I'm interpreting the question to mean, and we see this with a lot of businesses we work with, is that the manufacturer, the OEM equipment producer, or the IoT application producer is well convinced there is value in connecting their smart connected products or the devices in the field, but they have to convince the end customer, right? So in the case of an OEM manufacturer, the person purchasing the equipment, that they should be communicating products information into the cloud, which they're on occasion people have there is some reaction that is well, I don't communicate that information today. Why should I communicate it? And I think depending on the industry, the answer varies, but it starts with you need to demonstrate to the customer that there is clear value for them to provide that information. Many industries do it within uptime, or SLAs. So they offer different levels of service agreements. If they're communicating information, you're buying a certain type of service plan. If you're not communicating information, you're buying an alternative, right? So it's the customer's choice. Do you want to send that information and experience better services for less money, or do you not want to communicate that information? So that's one tact. The other is to provide the end user with new applications that they can derive value from. So in the case of medical equipment manufacturer, Gettinga, who sells their equipment today that comes along with apps for the hospital technicians, right? So it greatly improves the hospital technicians' productivity. That's providing customer clear value, right? So that the end customer's employees or the end customer themselves will have a better product experience as a result. So that's the way. You have to demonstrate customer value in order to get them to connect.
Great. So kind of moving along also with convincing customers to accept being connected, another question we got was, how are you addressing security in your current implementations and offerings?
Yep. So Scott, do you want me to take that?
Yeah, please, Arvind. That'd be great.
Okay, great. So what we're seeing is, right, so one is, of course, there are industry-specific standards which we need to follow. For example, healthcare, that's a very elaborate set of guidelines and so compliance issues that we need to tackle. So we do have a very good structure. And from a business model perspective, manufacturing industries, they too have their own concerns around sharing data, sharing very sensitive data when it comes to equipment performance and things like that. So one way, and of course the components and the tools that we use, they do provide quite a lot of features around that. And so first is, of course, with respect to the encryption of data itself. So where we have options of doing 128 to 56-bit encryption, using X501 certificates and etc. to wrap up the data. That's one. And then in the second level of security is in terms of accessing this information itself. So we do have different ways of wrapping up data. For example, if you have furnace, so furnace IDs and then having sensors, mapping the sensors back to that, using different kind of asymmetric keys to ensure that access to that is now and so being authorized, and so both from a human perspective, but also from a machine perspective, so that you don't have data collisions. That is one, and then you also want to control access for a gateway to access data from a given particular equipment. So we go to that extent of doing that, and ThingWorx provides us that kind of granularity in terms of controlling these access mechanisms, in terms of controlling the data and so transport mechanisms, in terms of and so setting up the right kind of authorizations, setting up the right kind of and so control lists, and etc. So we do have those kind of features in ThingWorx, which is what we are leveraged fully. Now, one aspect of that is, of course, where if a particular enterprise doesn't want to actually expose its data out into the cloud, we also use the on-premise. We use different kinds of architectures to support that and to ensure that data is anonymized before it actually gets sent out of the on-premise thing. So that's pretty much that's how we're actually addressing security. But there are a lot of industry-specific scenarios which we also work with on that.
Great.
Okay, great. Another question we got was, how will all of these IoT devices ultimately be connected, and where will the real business and customer value be for your organization?
So, it seems like, Arvin, maybe I take a pass, and please again add anything if you think. The question was, sorry, Lauren, was it how or where are the IoT devices being connected?
Yeah, it was how will all of the IoT devices be connected, and where will the real business and customer value be?
Okay. So the answer of how is via multiple methods, right? So today there are multiple standards for communicating information from a product across a network, and different ways of communicating across a network, whether it's mobile or directly into the internet. So some products are going to be connected via Wi-Fi. Some are going to be connected via cellular modem or cellular connectivity rather. So I think there are multiple ways of connecting information, and there are multiple standards which all need to be supported. So that's the first answer. And then how are businesses driving value? And I think there are multiple ways. I think the early use case, right? The early use case for industrial equipment or fixed equipment is in the service scenario. For consumer products, it's through these new great customer-facing capabilities, but also this relationship between, that previously didn't exist between the end customer and now the manufacturer. That's sometimes true in the medical device industry as well, right? Where you may not have a relationship with the person who's running your equipment, and it's an opportunity to form that relationship. So there's tremendous business value by in numerous ways, but I think we see a lot in service, and then optimizing other internal business processes as well. So it's a broad it's a broad answer. There's tremendous amount of value. And it's just demonstrated by that 6.2 trillion in new economic opportunity. I mean, it's a giant number. That is the economic opportunity of our lifetime. So it's rich with opportunity. Arvin, I don't know if you have anything to add to that.
Yep. Yes, Scott. And so what we're seeing on the ground also is that and especially because IoT itself spans on some multiple technology grounds. So you have sensors talking to different kind of devices. Those devices having to aggregate data in multiple kind of network formats, and then all of this then being aggregated in the form of gateways, and then from the gateways onto the cloud. So if you look at it, right, so there are multiple protocols, so which are colliding right now. But what we're seeing also as a trend is that there's a significant effort being made in terms of actual manufacture. I would say the network equipment manufacturers, where they're now beginning to support multiple kind of protocols. For example, one established way for sensors to talk to each other is a wireless HART. Right, and of course, the other way of this thing is what GE has been pushing as a standard for quite a few years, is the ISA standard for wireless communication between different kinds of industrial equipment. Now there are devices, right? So we just standardize this as part of their offering. Yokogawa provides that. Intel is also building a lot of these protocols into it. So what we're seeing is, and so what's happening is much faster than probably in any other trend earlier. This particular standardization, the support for multiple protocols, right, and etc. Because what has been installed in all of these industries is not going to go away. Nobody's going to rip and replace whole packaging systems. Nobody's going to rip and replace whole window and furnace equipment. Nobody's going to rip and replace all of the engines running around the world. More than 25, 30 million engines are running. So which is why the equipment supporting that is where the transformation is happening. And what we're seeing is that these protocols are converging very, very quickly. There are so many consortiums which even we are a part of, right? So whether it is Alljoin, whether it is the Industrial Internet Consortium, whether it is IoT World Consortium, etc. So all of these alliances are pushing this very, very hard, very strong, and it is also being supported by a lot of the IoT equipment side of it also, networking equipment, sensor design and manufacturer. So that convergence is happening very fast, and we think in the next about a year or so, at least whatever issues are facing in terms of this level of the sense of conflict will definitely have decreased down pretty significantly.
Great. I think that's all the time we have for today. We've hit the top of the hour. But like I said, we'll be sending out the webinar recording once the presentation is made available. And if there are any unanswered questions that people have, you can ask our speakers directly then. Thank you everyone for joining, and have a great rest of your day. Goodbye.
Thank you. Thanks everyone. Bye.